Alright, let's look at an example of Kramer's rule. Let's just set up something made up here. Let's just do 1, 2, 3, 4, 5, 6, 7, 8, 9. Some matrix times x1, x2, x3 equals something here. Let's just say 10, 20, 30, just so our numbers are recognizable. So we have something in the form of a x equals y, and we want to know what x is. Okay, so for Kramer's rule, we want to find the solution. It says that x sub I is the determinant b sub I over the determinant of A. Okay, so A is this full matrix. What is b sub I? Well, b sub I is this A matrix modified by taking what we've called y and putting it in the position of the x we're trying to find. So say we're trying to find B1. So we're looking for the x1 position would be the first column. We're going to put our y, 10, 20, 30, in the place of all the coefficients that multiply x1, and then we put the rest of the matrix back as it was. Okay, so this is our B1 matrix. So to find x1 then, we're going to say x1 is the determinant of this, 10, 2, 3, 20, 5, 6, 30, 8, 9. The determinant of that, our B1, over the determinant of the whole matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we get, that's x1, and now it's just a matter of doing a bunch of determinants here, calculations. Let's just, I don't know, let's just go down this column. So 10, eliminate this first row, first column, times 5 times 9, just write it out I guess, minus 8 times 6, minus 20 times what's left over from that when we cross out that row and column, so 2 times 9 minus 3 times 8. And I'm out of room, so let's go back up here, we're getting messy. Finally 30 plus 30 times, eliminating those two, 2 times 6 and 5 times 3. 2 times 6 minus 5 times 3. Similar process for down below. We'll take the first column again, 1 times 5 times 9 minus 8 times 6 minus 2, I'm sorry, we're doing the first column, 4 minus 4 times 2 times 9 minus 3 times 8, and then 7 plus 7 times what's left over, 2 times 6 minus 3 times 5. Alright. Okay, and then looking at this, negative 3 plus 24 minus 21, looks like we're getting a 0. So our matrix is singular to start with, so I made a poor choice, I believe, for this. But anyway, hopefully you can understand the process. This doesn't work. You can't divide by 0. But hopefully you can understand the process for Kramer's rule. And similarly then, let's just set up the second one so you can see what we would get, even how to do it anyway, even though it won't work because of our 0 problem, because of my funny matrix I made up. Let's go ahead and find out what is x2 then. Well, x2 is b2 determinant over the determinant of A, and so that would be the determinant of b2. Now we're going to take our answer column, put it in the place of the 2 position. So we'll have 1, 4, 7, 10, 20, 30, and then 3, 6, 9. And so that's our B, and then again just the determinant of A underneath. And so once you calculate the determinant of A, and hopefully it's not 0, then you can do, this part is not needed to be calculated every time. You can just divide by, and get your number for your answer for x2, and similar process for x3. x3 would be b3 determinant over a, and b3, take our answer column, put it in place in the third position. So 1, 4, 7, 2, 5, 8, 10, 20, 30 over the determinant of a. And plug it in, get your number. And there you have it.